Thank you. No, you can see from my title, I'm really obsessed with this. I'm really obsessed with this idea of making it easy to work with data. My team works really hard every day to figure out how we can do that. And today I want to kind of give you a whirlwind tour through what the data platform looks like at Netflix. And I want to explain what that looks like. Unfortunately, it's going to be a lot. And what I don't want you to go away from this talk is thinking, hey, what Netflix is doing on their scale or the problems they're trying to solve are necessarily mine, and I should try to build that data platform, because I don't think that that is important for you. What I do want you to take away is this question that I have: how do you decide what to build? Because it's really easy for me to say that I'm going to make it easy to work with data, but you're going to be like, well, what the heck does that look like? And so when I normally answer this question for people, I kind of use this rubric, or I have in the past, and it kind of goes from left to right. I think about the users I have a vision for what that data platform should look like, and I look to my peers, and I want to dive into that a little bit further before we talk about the platform. For me, my users are doing a lot of really interesting things: machine learning, analysis, visualization, doing really great things with our data to really move Netflix forward. And so at the end of the day, when I'm thinking about making it easy to work with data, I'm really thinking, how can I focus those users, those people that are really smart working with data, how can I focus them on that data problem rather than having to worry about the data platforms behind it? Because at the end of the day, the users could kind of sum up their wish from me in one sentence, and that is generally, I want all the data you have as fast as I can possibly get it. And that's a problem for us because we have a lot of data, and we're not able to give it to them as fast as they'd like. But the thing about my users is they don't actually know how to ask for what they really need. That idea that I want all the data all the time isn't necessarily what they need at any one time to solve their problem. So we think a lot about what those users need to do, but besides just thinking about these users, we have kind of this vision for what the platform should be like. And this should be, if you're building a data platform, this should be you. This is the day-to-day exciting part. You have this kind of picture in your head that if we could just put these pieces together, everything that my company does, these data users, they'd be so happy. If I just did X, everybody would come to work and they would pat me on the back, go home happy. And we kind of have that picture in our heads. But what I have to be careful about with that is it's really easy to build the wrong thing. You're really excited about some tool. You think this is the greatest thing since sliced bread, or I guess in our case, the greatest thing since Hadoop, which is not very hard. There's a lot of things greater than Hadoop. But you think, I have this tool, it's going to be really great, we're going to use it, and you work on it, you go away for months, a year, and you come back and nobody uses it. And you've really wasted your time because they're off to using Spark or some other great tool. Or conversely, that great tool, it's really great, it does really work for you, but outside you, the community is moving, it's doing other things, and you really need to be focused on what they're doing as well. And that brings us to our peers, and that's why we come to conferences like this, right? That's why we come to Crunch, other conferences, read blogs, is we're trying to figure out what is it that my peers around me are doing. Whether that's a peer like me, who might have a lot more data, a lot more users than you, or just other people that are solving the same problems as you. In the best case scenario, the peers are really great because they've open sourced something that you can take and put into your environment and use to make your product, your data platform even better. But here's where I wanted to dive in, and this is where I wanted to start talking about my platform. The problem often when I go and listen to my peers talk about their platform is I don't really have the context for what they're doing. An example of this, like my best example, is the day that we went over to a company that was had this open source project that really felt like it fit a need for our company. And it was kind of interesting that there was a community growing up around it, a lot of devoted users outside the company. And so we thought, hey, we'll call them up, we'll go up and have a meeting. And they're like, yeah, we'd love to have a meeting to talk about that. And so we go in, and we're like, hey, all right, tell us about this tool you're using. And they're like, well, we don't actually use it. It doesn't actually scale for us. And we're like, oh, that's kind of weird. And their next thing that they said after that was, we really wanted to meet with you guys because we wanted to see what you were doing in the same space because we want to do what you're doing. And that's kind of the problem, I don't want to say that, like we're disingenuous or that like you should go away and look at these talks and say like, hey, that doesn't work for me, or they're selling me something. But really, you have to understand what's going on in those companies to really understand why they've built what they've done, or why I've built something that I think is easy to work at Netflix. And so let me give you that kind of brief rundown. Let's give you the context of what I'm doing that you would typically see or I would typically talk about. At the top here, this is our ingestion pipeline. So on the top, we have Keystone. We're pulling in, across Kafka, 500 billion to 1 trillion events per day into our data warehouse. Ursula is the tool that takes that and and moves that into tables based on event name, time, hour, and partitions that data so that we can use that. Incrementally per day, that's about 200 petabytes compressed. Did I say petabytes? I meant terabytes. Petabytes would worry me. That second one, Agathis, is where we take snapshots of our dimensional data. Our source of truth, is Cassandra for a lot of the back-end systems, like what A/B tests we're running, what subscribers we have, what's their status, are they on hold, are they in some A/B test, different things like that. And that writes another 200 plus terabytes into our data warehouse. Now, this is a little bit different. Incrementally, because those dimensions are changing slowly, we're only gaining in that second pipeline a couple, tens or 20s of gigabytes of data. But practically, we're re-snapshotting that data daily, so it looks like the same amount is coming through our Keystone pipeline. And this last one here, I debated on whether to talk about, and it's because there's a huge topic about what we're doing in this kind of other space. Netflix in the past and where we were was really focused on this internal data coming from our websites, data coming from things, interactions of our users, from our Cassandra data sources. But as we've become a studio over the last couple of years, there's been a growing need to get other data, a growing need to do other types of processing, and that's where we're gaining in that other category. So I don't want to dwell on that too much, but just know that what's changing about my platform, and part of the reason that my platform it looks like what it is we haven't been focused on those external sources as much. And here we get to the point where we look at what the data platform looks like to my users. We'll start from the bottom. We have a S3 data warehouse. In that data warehouse today, we have we have more than 100 petabytes of data, and right now it might be significantly more than 100 petabytes. Our growth rate is crazy in the last year. I believe at this time last year we had about 60 petabytes of data compressed in that. And I say the data warehouse. So the data warehouse, when we think about S3, we split compute and storage. S3 is the storage, but the data warehouse is the combination for me of Metacat, which tells me what tables I have, what schemas they have, things like that, and the S3 data. The processing engines that we're using, Presto, Spark, Pig, and Hive, less on Hive, more on the others, especially because those other three use Metacat directly. The processing engines, Presto, Spark, Pig, look at Metacat to figure out what data we have. In other systems, you might use the Hive Metastore. Hive Metastore sits under Metacat for us. We layer other data on top of it, but that's the data warehouse, Metacat and S3. Metacat also tells us what tables we have in Redshift. We use Redshift as well. We move a subset of our data from S3 data warehouse into Redshift to cache it for things like Tableau, MicroStrategy, and other situations like that. On top of this, I have this layer Genie. Genie, we're going to come back to, but really think of it as the execution engine. You ask the platform, here's the script I want to run. I want to run it on production data. Genie decides what clusters are available, picks the right one, picks the right configuration, runs it for you, and later on you'll connect back, asynchronously you can connect back to it and say, like, what happened to that job? What are the logs for it? Did it succeed? This dotted line above here is, just indicates there's a lot more services. We're not going to delve into a lot of those today, but there's a lot more that goes onto the data platform. But when we talk about the data platform, when our users think about it, these are the main things that they're thinking about. On top of this, we have Craggle and the Big Data Portal. We're going to talk about these a little bit more depth later, but I'll just say that the Craggle is, if you've seen the Lego movie, it's short for crazy glue. It glues the platform together. It's a library, a Python library that treats all these services underneath as if they were one cohesive whole. And the Big Data Portal is a website that we can use to come in and work with the data platform. And at that point, I've explained the context, and you might think, hey, this is really great. You've probably built all of this because you had a scale problem. Or we might dive into the different parts of the platform and you think like, well, that's interesting, it solves a particular problem. But really, the history of this data platform starts back a ways, and I want to give you a really quick whirlwind tour through how Netflix came into big data. In 2007, we started streaming. That was 10 years into Netflix's history. At that point, Netflix was not doing anything that we would consider big data. So 10 years have gone by, not needed big data. In 2009, Netflix decided, hey, the streaming thing is going to be big. We need to move into Amazon because we're going to go worldwide and we don't want to own our own data center. So we should move all our entire platform into Amazon. We became Amazon's poster child. And that was, really good timing because in 2010 we became a global streaming company because we started streaming in Canada. Yay, we were big. And at the same time, 2010, 9 and 10, that's when big data came into Netflix. We started using Hive to process our logs, and we started the beginning of our data warehouse in the cloud. 2011 came along, and this is when I came into the scene. In 2011, when I walked in the door, they said, hey, this is great. The entire Netflix site now runs on Amazon. Let's go crazy. There's only one problem. This is what was going on. The data warehouse was not in Amazon. It was this data center that had Teradata in it. We were double publishing all this data. So on day one that I walked in, this data platform, it was like, hey, how can we move this data center all the way up to the cloud? And we thought really hard about this, and so you can play along with me, and you're like, all right, okay, how are we going to do this? And like, looking at this picture, think. And I know that you thought of this with me. Let's add pig to this situation, because that's going to make everything better. Now today, if you've thought about pig, you're probably thinking that's a pretty crazy decision. But if you go back to the way we were thinking about things, our peer companies were using pig at the time, so it made sense. Our users were a lot of analysts. They wanted to do SQL, so moving them to an environment where they were programming really didn't make sense. We had a few options there, like scalding, MapReduce, a few other things. We didn't really want to put them into Hive. We didn't really think we could move that situation. So our vision for this platform was something that was programmatic. We didn't think pig was really the answer, but it was the closest we could find to something that worked. So that when you look at Netflix's data platform and you're wondering why we got pig, it was really, at the time, it was the best situation we could do. On the back end, our ingestion platform, we built Agathis so we could start moving that data across. So we got here. We've won, we've got a data platform, we can move into the cloud, we can get working, and we started thinking, all right, well, how are we actually going to make that happen? Because, we can't just ask our users to come and write pig scripts and suddenly run on the data platform when nothing really works together. So we started thinking about what we needed to build. And we started thinking, how are we going to scale in the future? And if you look at this now, it's really easy to see that we were going to scale pretty fast. We were going to go into originals. In 2011, when I started this, we said we were never going to do originals. We thought we were going to, slowly go into companies, different countries, and that by 2020, 3 years from now, we would suddenly magically have 100 million subscribers, and that would be amazingly large. That happened this past year. So looking back at it, it was kind of like we should be thinking about scaling really quickly. We had 4 petabytes of data. We had big data, but we weren't thinking we were going to move as fast as we did. So what we were thinking about for the future was, let's think about how to do that migration to AWS. And for us, what that meant was we needed a service that was going to allow us to build for the future. We thought, in the future, we might want to get rid of pig. We have multiple clusters. There's a lot of problems going on. And at that point, that is when we designed Genie. The whole point of Genie was to abstract away from our users the need at that time to know about the clusters, to know about what clients they needed. Really, we just wanted to give them a simple REST interface that looks kind of like this today, to say, here's the script I have, here's the type of data I need, here's some other information about it, go run this for me. And so that's why we built Genie. We thought, if we have this abstraction, we can do interesting things in the future. We're not sure what they are. They weren't about the scale at the time, but they gave us a building block to build on. At the same time, we thought, like, the other thing that we know we're going to need, 4 years down the road, 10 years down the road, is we're going to still be working with data. So we really need a system that will federate all this data together. We can see what tables we have, discover them, layer additional data on top of it. In this picture, maybe you can kind of see Metacat does things like it converts types from one system to another. In this case, we're moving Hive to Pig. We're adding additional schema information on top of it. This is on Hive. We could have stored it in the Hive meta store, but we also were putting this on top of our Redshift data, our Teradata data. So any data that we had, we could layer on information. And today, kind of skipping ahead real quick, we layer a lot of things on, like cost, who owns this, when should we delete this data, different things. But this idea that we could have this metadata service that we could layer on metadata was really appealing to us. It was a building block for something that we wanted to build. So if we put those into the picture, our picture gets closer, a lot closer to what that end goal was from just having Hive and S3. It's a lot closer to what the data platform is today. But we weren't really stopping there. At that point, we were moving up into the cloud, and our users immediately had problems. We had made it easy for them to submit jobs and to run on the platform. They did not find it very easy. One of the first things we did for them was we built Lipstick. Now, Lipstick is a tool that just shows you the logical execution plan of a Pig script. And why we built this really was our users were coming from writing SQL, and they were just like, I have no idea how this map reduce thing works. My job is slow. It fails in the middle. Please tell me what's going on. And so we thought, well, why don't we just build you a tool that shows you what that graph's going to look like, shows you like when that fails at step 57, click here, go find the failed job. So we built this tool really quickly to meet that need that they were feeling. And because we had built Genie, the nice thing, we were kind of figuring this out as we went along, but Genie worked really well for us because those Pig scripts they were asking us to run, suddenly we just asked Genie to apply Lipstick to it, and suddenly they had the graphs they were going. For no change to the user, everything just kind of worked naturally behind the scenes for them. We weren't done there, though, because even though the users could go to Lipstick and find their errors, their real process was, I run a job on the scheduler, it fails. The scheduler gives me a link to Genie. I go to Genie, and the Genie gives me a link to Lipstick. I go to Lipstick, and Lipstick gives me a link to Hadoop. Hopefully I can go there, find the logs, and find out what really failed. And we thought that was a miserable experience. Our users did too. They told us every day that it was a miserable experience. And so we thought we would build a tool called Pensive, which would do that manual work for them. And really what Pensive does is it goes out to Genie now that we have Genie and we can see all our jobs, it goes out to Genie and says, hey, this job just failed. Tell me what information I need to get. Do I need to go to Hadoop? I'll go and find those logs for you. Do I need to go to S3? Do I need to go to other system? So I can bring that all together, classify the error, and tell you exactly what's going wrong so that you can fix it. Even better for our users, we started classifying those jobs, and if that was a platform error and restarting would work, we would restart those jobs automatically for you. And that made our users much happier. We wanted to know, while all this was going on, how data was flowing through our system. So here, we started building Charlotte. Charlotte is just this idea that we wanted to publish data, or we wanted to get the lineage of every job that ran on our system. What table did it come from? What does it go to? Because our users were asking questions about, like, who's using my table? Or who wrote this data into my table that shouldn't be there? In this example, you can see that we have an ETL job that's writing job into this table name, strangely named table name. And also, somebody's running ad hoc queries to update this table. Probably not a good idea. Maybe it is, maybe it's not. But this way, you could come in and see that here's what was going on with your table. And Charlotte looks like the reverse of Pensive. We just publish data to it. When a Genie job runs, it tells Charlotte about it running. When Pig or Hive or anything else is running, it tells it about the data that it read and what it wrote to, and it pushes that to Charlotte. The same way with our databases. Teradata publishes in, Redshift publishes in. And also we push S3 access logs. Because we had built Genie and we had Genie IDs everywhere, we started to push that all the way down into our access logs so we could see for every read and write from our S3 access logs what job it was associated with. So we had really fine-grained information. And so at this point in our whirlwind tour, we've built a platform. We're moving up to the cloud. We've given our users the ability to see what's going on so they can kind of self-service themselves. And we thought, like, what is it that we need to do next? And the next thing that we wanted to focus on was building better patterns. Because now that we could see what they were doing, we were really kind of shocked. The first thing that we wanted to look at was Teradata. This isn't really a great pattern when we were gaining, petabytes of data. We were pulling some subset of that down to Teradata, and we asked our users, well, why are you doing this? We can see that you're doing this. We can see that you're not moving all this thing up to the cloud. What's really holding you back? And there were two big things that we did. The first was, I told you they wanted access to all the data as fast as possible, and so we introduced Presto. Presto is a fast query engine that came out of Facebook. For us, that took the time to run Hive queries from minutes down to seconds in a lot of cases that people were dealing with. So this gave people access to all the data that they had and a speed that was, somewhat comfortable. Still not the speed of Teradata, but they appreciated that because they only had a subset of the data in Teradata. At the same time, this is when we introduced Redshift because we realized, with the flexibility of being able to spin up Redshift clusters and point them at our data and ingest it, it was a lot better for our users to just kind of do that ad hoc rather than having this really big database in the data center. And plus, we were still in the process of wanting to move out of the data center during this time. So this is why we have Presto and Redshift. It was really just we were going really fast, and our users were like, I need data faster. How do I do that? Redshift, Presto. Craggle came in at the same time. And why Craggle came in was we realized it wasn't easy to program against the system. We had Charlotte, Lipstick, Genie, Metacat, and it was really great if you understood how to use those different interfaces. But together, it was not a cohesive platform from the point of view of our users. So we thought, why don't we write a single language that makes it really easy? Now, if you're a Python user, I apologize. Don't look at the screen real close because this is not going to look like really idiomatic Python. But for our users, this was just a kind of a builder pattern that they could kind of think through, like, here's what I want to do. I want to give it a script. I want headers back from it. I want to execute. And that would asynchronously run their job and bring back. And what you can see here is writing a Hive job, a Presto job, a Spark SQL job. We could have gone on Redshift, Teradata. They all look the same. They didn't have to worry about what was going on. That was going to call out to Genie, do the right thing for them. And they could program against the platform as well as we could. And to dig into this just a little bit more, you can see here that we've built other tools that kind of make the platform seem more cohesive. Transport here takes, you tell it, here's a Genie job that I want to run. I want to run this Hive job. I want to put this into another table. And it might look at that and say, really what you really want to do is run a create table as select, and maybe you don't want to run that in Hive, maybe we want to run that in Presto for you. But the platform then can decide for you how to use what you're telling it that you want to do the right thing, the thing that we think is more efficient. That might be move data from the warehouse to Redshift, or it might be move data locally into a data frame. You can kind of express that need and let the platform handle that for you. And that made it a lot easier for our users to program, the ones that wanted to write code against our platform. They no longer had to think about Genie. And so there's this line into Genie, but really you can think about Craggle as having a line into every different place in our platform. It can touch all of it, all the way down to S3, which I don't show a line here. And so at this point, we're like, this is really great, but our users, a big chunk of my users, they were analysts, they were not programmers, they had no desire to write code against the platform. They weren't really writing ETL, they just wanted to write queries or see what tables were. And so we thought, what we really need here is to build an interface. We're going to treat this interface like it was the big data platform. The big data portal in the minds of our users should be the big data platform. Our goal was to hide everything that was going behind it. You want to come to this screen and be able to write a query against the platform on day one. You can do that now. You come in, write the query. You still have the flexibility. You can ask it to run on Presto, Spark SQL, Redshift, Teradata, wherever that is. You have the flexibility to do that, but you no longer have to write code, which was a big feature of what was going on before. Some other things that it does, going back to Metacat, is it allows you to use Metacat in the way it was designed. You can go and search for your tables. Do you want to go and find all the tables that have ESN on them because your goal is to clear that all out of our data. That's not data that we should retain. You can go and query for all the tables that have ESN on them. And this is important because although I didn't mention this earlier, another part of our scale is we have about 160,000 data sets in our data warehouse. So it makes it really hard when you don't know what you're looking for to go find that. So we get here and I really want to stop and say, man, it's 2014, we've built the data platform, we're done. But right at that time, we suddenly realized that that original plan of scaling, like it's going to take us 10 years, wasn't really happening. We were accelerating a lot faster. And while we had made it easy for people to do things, there were a lot of problems with the underlying architecture. One is, if you look at top here, this wasn't Kafka at this point, it was Suro. And Suro was great about bringing these logs in, but it had one bad feature from the point of view of our users, and that was it was lossy. And it was lossy in a way that they couldn't predict. Sometimes you might lose an hour of data, or 10% of an hour of data, or over several hours. And that made it really hard to reason about the data that was coming down the pipeline. So during this time, this is when we brought Kafka in, to give us predictable performance about how data was coming down into this pipeline, guaranteeing at least once delivery to most of our users. From the data portal, we brought in Spark. We had been playing with Spark since 2013, really early into Spark. We thought it was going to be a good replacement for Pig. Remember, when we picked Pig, it was kind of arbitrary. We thought we wanted something to replace it, but we hadn't found anything yet. At this point, we realized that the writing was kind of on the wall. In order to scale, we had to start dealing with something that was better, more efficient than Pig. And so we brought in Spark so that our user could start to write jobs that were more efficient. And lastly, and this is not something I have time to dwell on, we started containerizing everything that we were doing up top. All our Kregel libraries, the big data portal, are now containerized. We put them in Docker containers and start releasing things. And in fact, at this point, we started releasing multiple 20 times we would release production code per month. We're doing that a lot faster today. And there were so many changes that people wanted us to do, so many things that we wanted to do. We wanted to be able to build that, release that, and test that constantly. And because I mentioned it, at this same time, we were becoming a studio. We were starting to think about other types of data that we needed to pull in. So that same containerized environment became what our other pipeline was. We want to run containers on our federated container server, I guess Mesos is what we're running to run Docker. Different types of ETL that just didn't fit in, but whether that be a machine learning workload that was running R, or just a script that had to go out and touch an API and it didn't feel like it really fit into Spark. So we've really gone fast through, surprisingly fast, faster than I expected, through the 5 years that led up to this. And if we look back here, you can see that the platform looks like what I showed you at the beginning. And this is what I wanted you to take away from this. Remember, this platform did not come into being because we suddenly thought, what we really need is this execution service, and it's going to help us solve all these problems. It was a building block that we thought that we needed, that we knew that we were going to scale in some way, that we were going to throw things away, that we were going to change, but it was never a point where we thought, Genie is the end, that everybody should go out and do the same thing, solve the same problem. This was a problem that our users, our platform had that you might not have. So what's been going on for the last year is we've had the data platform. It's not changed significantly. We've been working on two big things. I'm going to just show you a few of them, but in 2016, we worked a lot on better infrastructure. We were still in that midst of scaling. We had built Kafka and things like that, but our data platform hadn't changed. We were still running on EMR. We'll talk about that in a moment. In 2017, thing that I'm kind of collapsing together, what we worked on was user experience. And what we've been working on are making the big data portal better, making it easier to use, custom visualization, different things where our users, the web interfaces that they're touching, really focusing on the design and work on that. And I can do that because I have 400 users that use the Big Data Portal every day. I have close to 1,000 users now of my tooling at Netflix that if I can save them time, if I can make that slightly better, it's worth it for me. It's worth me investing in that ease of use, where I wouldn't have necessarily done that had I not had that user base. And I definitely wouldn't have done it 2 years ago. But the parts that I wanted to show you was one, we moved to Spinnaker. Now, I would not, when I'm talking to other people and they're like, well, I want to run on Amazon, I want to run an EMR, I say, that's great. We would be there, we were there for a long time. What was true about Netflix is this used to be undifferentiated heavy lifting for us. That would be just the phrase that we, like, should I build or buy, right? If I can't bring anything to what I'm working on that's going to move the business significantly, I shouldn't spend a lot of time on it. So for us, Amazon EMR worked perfectly well, but we had this internal system where Netflix platform was being built. It was being built on top of this tool called Spinnaker, which just allows you to orchestrate microservices in the cloud. It's our continuous integration and continuous deployment system at Netflix. And so we realized that, some of the things that we really wanted to innovate on, we could do better if we were handling that ourselves. So rather than continuing on Amazon EMR, we started building on top of Spinnaker, building our own Hadoop distribution, figuring out how to make that work well on AWS, which has something that we had left to Amazon for a long time. The thing that I'm really excited about was the data platform existed, and we talked about how we were pushing all this lineage out. We were also pushing all other kinds of events coming out of this. When your job ended, I have a Genie job, I have information about it. When a Hadoop job ends, I have metrics. When a table is updated, I have a table update event or metadata has changed. And we looked at that and we thought, really, it's time for us to start thinking about building new parts of infrastructure, and we built 2 things. The first has been Microbots. Microbots you can think of as an if this then that clone. It really is just a way for us to build triggers to say, like, when something happens, in this case, when a table updates, I want to go do something. In this case, go run a UC4 job. It could be a Genie job, right? Whatever we can plug in there, send me an email alert. And allow our users to go and compose our platform together, where a lot of our users, and we didn't really talk about our scheduler, a lot of our users were building things using Craggle. It was easy for them, but they would go and build the same thing. They would go and build something that would wait. It would poll every 5 minutes. It would pull our metadata store, or it would pull Genie to say, like, what's the state of what's going on, so it could decide to run. And we thought, well, that's really great. That's a good use case, but we really want to know that's going on, because that load, as now thousands of jobs are just sitting and polling our services, every second, every minute, it's not really great for us, and we can make this a lot easier. So we built Microbots to kind of solve some of those problems. And the other problem that we had and that we were trying to solve we wanted to make easier for our users was for them to understand when we were telling them that, it's really great that you're building this new thing. We love that you can come and schedule this. You have Genie, so from your laptop you can start running jobs in our production system. Seems kind of crazy. It is kind of crazy, and some days it doesn't work out. And so we would go to the user and say, like, hey, your job is using 1,000 hours of CPU time on the cluster and everything else is slow. And our users were like, that's great. It's working for me. And so what we're thinking we should do, we thought about this a lot, but we had this kind of epiphany that really what we should go and tell them is about cost. Because our users were constantly thinking, like, hey, this job takes an hour. It would be really great if I could run it on a cluster that was totally free, so that I could run it completely in parallel, and it will take me 5 minutes, and then my day is great. Right? But they hadn't really improved anything. They'd just taken that length of time and adjusted it to run in parallel. Cost gave us a metric where we could go and talk to them and say, like, you haven't really changed anything. It's still costing us resources to run your process in the same way. That problem where you were taking up a large part of the cluster, we can tell you now in dollars how much that costs. So you can just think, like, compared to the other things that are going on, is that really worth it? If it's still worth it, we have the ability to spin up new clusters, let Genie route data to it. That's not a problem, but we could have a conversation about what was really going on. So we built this insight tool, and you can see here a little bit. It's just telling me, how many times this job, in this case, just a select statement that's running 1,000 times per week, and it's costing 1,250 jobs, or $50 jobs. It's also started to give insight along with that, because we didn't want to just, say, here's the cost of something change. We wanted to give our users insight into something they couldn't see before, and we started building insight into what was happening over time. So we took those Genie jobs, and now instead of just saying, like, hey, your Genie job ran and you understand it, we just start saying, here's how your metrics are going over time. This is the data that you're reading over time. This is your cost over time. So that we could start to say, like, hey, this is going to be a problem, or here's something you should look at. What I'm not showing you here is we're also doing work to say, given your job has run, here are different things that you should look at. Maybe your garbage collection time is too high, or you're running with the wrong number of executors, you're wasting resources. Here's things that you can take actions to make your job either more efficient, cost less, or run faster. So that is the job insight tool. And at this point, our whole goal, coming back to that question, how do you decide what to do? We're thinking again. I'm thinking again. I've been thinking for the last 6 months about what is it that we're going to need to build in the future. And the thing that we're going to build next year is what I've been telling people is the intelligent platform. So I want to take you back to the beginning. It occurred to me that when I had been asking this question, people had been asking me, well, how do you decide what to build? I'd been saying, hey, I go ask the users what they're doing. I think about the vision of what I want to build. I go look at my peers, and it makes total sense. But I had been building all this time, sprinting, working really hard to make it easy to work with data so that Netflix didn't operate on that. Netflix is insanely data-driven. They care about data for everything. If we're going to change something on the website, it's going to be tested. There's going to be data around it. We're going to understand, how that affects retention. But the decisions we're making on the data platform are not data-driven. They are, as I just described, us looking at what's going on and making decisions based on what we think our users really need. How can I make it really easy for them? So I want to continue to be obsessed about making it really easy for my users, but I really want to have the data that we're collecting drive those decisions. Rather than building a new feature or optimizing different parts of the platform, we should be able to look and answer questions. An example that I've given my team is pensive. So if you remember back to pensive, I know I went through a lot of these things really fast. Pensive is our tool that looks at a job when it fails and decides, should it restart it? It classifies the error, says, like, here's the problem. And so my team came to me and said, we know that a huge chunk of our work is unclassified. There's still 50% of errors that are happening that we don't currently have a classification for. We'd like to use machine learning on it to figure out whether we can do better. And I was like, oh, that's really great. That sounds really exciting. I love using machine learning. Sounds like a novel case. But then I asked them, hey, okay, let's say that we get this right, that we can restart every job successfully, right? We can decide that this is a platform error and restarting will be correct. The thing that should really drive us doing that is deciding what's the cost of us restarting and failing incorrectly, right? So think about this. If I say, hey, this job failed and it's unclassified and my default is to restart it and it fails again, the cost of running that job is the cost of the platform. If restarting is the right answer, if we've correctly classified everything, then that restart will always succeed or mostly succeed. And my team didn't have an answer for me. They didn't know. They didn't know what the cost, how much restarting jobs that were going to fail again cost us. So they couldn't tell me if us spending any more time was actually going to improve our ability to restart jobs correctly or to get rid of the false positives. So I want to leave you here, and then I'll be happy to answer questions. I'd be happy for you to catch me later and to talk about the real things that we're doing, a lot of the things that I haven't talked about that are really interesting on our platform. But I have this problem that you don't have probably, and that is I have hundreds of terabytes of information about how people are using my platform. Because I built Genie, because I built Medicat, because I built the Big Data Portal, because we've been collecting all these things for different things, we've been collecting tons of usage of our platform. And that's where, in the future, my answer to how do I decide what I'm going to do is going to be that we're going to be looking at the data. We're going to use that in the same way that Netflix is using my platform to drive forward the business. I want to be using our data in the same way. So with that, thank you for listening. I hope that you go away from this and you're inspired not to copy my platform, but to really think about why it is that you have a data platform, what you're doing, what you're trying to accomplish from that. And from that, use that to listen to all these talks you're hearing today to figure out what parts of that can you take back and really make your own. So thank you.
Charles, thank you so much for your speech. We're going to have a few questions. And thank you all for using Slido so that we've got the opportunity to ask these questions. So, question number 1. If you were to redesign data warehouse at Netflix and build it from zero, so from scratch today, what would you do differently and what technology would you use?
It's a really good question. Honestly, I would probably start in the same way. I would build these core services because I think that of all the things I've done, all the things we built, having Genie and Medicat and now Microbus, our core services, makes it easy for me to come and build something new and build on top of what we've done. Now, technology-wise, I think that I would really, I'm really building towards a world where everything's containerized. So I'm pretty sure that how we build the platform, the tools we pick, would be based on how well I can containerize those and build a platform on top of that. But more than that, I would probably be building on Spark, just because right now, Spark is the easiest tool for us to use. And it's a bit of a cop-out because we're using it, so I wish I had a better answer for you. I kind of like what we've done so far, I guess.
Okay, good is good enough.
No.
No. In a word, no. Okay, it's
easy.
Not easy.
Easy is good enough.
It's not easy or efficient enough. Okay, so you've built a lot of tools for your own need. Do you have any data that can tell what the ROI of building these tools is, and is it possible to measure that?
It is possible to measure that going forward. It's not going to be easy, and so I'm working really hard to make it easy to work with data. And so like the thing that I really want to measure, is how, if you could take, you didn't have this data platform to work on, you had something else to work on, the difference in time that our data users would be doing, right? So you want to say like, hey, this is their salary, how do I equate that over? So we're going to be able to measure like how much we're using these tools and things like that, but we're not going to be able to tell us if, in pure dollar cents that we're going to do that. The metric that I'm going to use on this is how fast we can process the data that we need to do daily. We're growing super linear in data, in jobs, in people at Netflix compared to our subscribers. My whole goal over the next couple of years is to bring that back so that our data growth, our need to hire data employees at Netflix, and the amount of processing it takes us to do, the cost to process, comes back in line with our subscriber growth. Or I guess we could just bump our subscriber growth up to exponential, and that would solve my problem too.
Okay, so we have a crucial question here.
Yeah.
Real deep and meaningful. Obviously, Frank Underwood is in the audience with us today. He wants to know, will there be House of Cards Season 6? Personally, I'd like to know Frankie and Grace Season 4. But anyway, that's a by the by.
You know, it's probably in my data somewhere, but I actually don't know. Right now, we have so many originals. I think there's somewhere between 400 and 600 coming out next year.
Oh my gosh.
That I hear about it in the news now the same way that you do. It's really strange because I serve all the people that know this stuff. I should ask them.
Yeah, okay. So you need a hotline almost.
Yeah, I really fell down on that question. I should have been prepared.
Okay, so you've built some tools to empower Netflix. Are you planning to release them as open source? And this is our final question.
Oh, yeah. This is a great question. Genie and Metacat are open source. Agathis is open source. The problem with open sourcing, and you've probably dealt with this if you've open sourced anything, is it requires me to think a lot about support, right? Like build this so that the community can use it. My team's goal is to make it easy to work at Netflix. And so I build things that are really tightly entwined with what we're doing. They're hard to rip out and say like, hey, take this. So my goal is not to not open source it. Really, my goal would be to put everything I do online on GitHub so you could use it and see what we're using. But without you adopting my platform, a lot of the tools that we're building, a lot of the things that I talked about today are hard to rip out and package into something that's easily reusable. So my answer there is we're probably going to open source more, but it's going to be a pick and choose by things that really we can break out and really would be effective for other people that we think other people could use.
Brilliant. Thank you so much for your time and your talk. We have this wonderful picture. Should we show them?
Oh, yeah.
So we have this wonderful picture for you. We really appreciate you being here and the information that you shared. Thank you so much. Let's give them a hearty clap.